Okay, ladies and gentlemen, so let's continue with our discussion from a few minutes ago. I have broken down radical 32 into its prime factorization, right? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Now, we're going to speed this up a little bit here, but let's remember that radical 2 times radical 2 is just 2. Every pair of the same radicals will give us that nice whole number. So as I simplify this, right, radical 2 times itself is 2, it happens again, and I'm left with a single radical by itself, so I'm going to carry that down. Finally, 2 times radical 2 is 4 radical 2. Okay, now as we just discussed, some people might look at radical 32 and say, well, I can break that up into radical 8 times radical 4. Now, square root of 4 is nice, that's just 2. All right, and I like to just keep crossing things out, as I said earlier, just to remind myself that the square root of 4 is 2, and that's a whole number. The radical symbol is gone because I took the square root. But now, a lot of times people will do this, and then, we usually put the coefficient out in front, and they'll finish, and they'll be done here. But this is incorrect. It's equivalent, I should say, but it's not completely simplified. We should be breaking radical 8 up into radical 4 times radical 2. All right, now just because it's the same question, we're going to get the same answer here. I want you to notice the shortest way possible. The shortest way to simplify any radical is to try to decide what is the greatest perfect square that divides into it. Well, now that we know our final answer should be 4 radical 2, think about it. The square root of what gives you 4? Well, that would have been 16. Right? So right off the bat, if you use the highest perfect square, radical 16, well, that square root would be 4, and we would have 4 radical 2 right off the bat. Okay? So let's try that down here. What is the greatest perfect square that divides into 48? Well, it is actually 16, right? 48 is 16 times 3, and the square root of 16 is 4. So 4 radical 3 would be our final simplified answer. All right, 125 over here, right? What is the highest perfect square that divides into 125? Good, that's going to be 25, right? How many quarters are in $1.25? 5 of them, right? So 125 is 25 times 5. That's a nice perfect square. That's going to be 5 radical 5. Final answer. All right, good. So now what I'd like to do is show you a couple examples of where, there's a couple steps in our simplifying. So the first example 2 here says to simplify radicals that have variables in them, right? Simplify radical with variable. So what I want to do is I'm actually, right off the bat, I'm just going to split up the numeric term and the algebraic term, right? So in this case, I have the square root of 16. That's nice because the square root of 16 is just 4. Now, ladies and gentlemen, what is the square root of x squared? Well, think to yourself, why is the square root of 16 4? Because 4 times itself gives you 16. So what times itself gives you x squared? And that's just going to be x. All right, very good. Now, when we have a non-perfect square, I'm still going to take the same approach. I'm going to divide these up, or split them up into factors, right? 18 times x to the 4th. The square root of 18, well, it's not a perfect square, so what I'm going to do is split this up. What is the highest perfect square that divides into 18? Good, that's going to be 9 times 2. Now over here, what I'd like to do is this. X to the 4th is really x times x times x times x, right? So think back to what we were just saying with the 2's before. If I have radical x times radical x, sure, that's x squared. But what is the square root of x squared? Well, we said every time we have a pair of the same product, it'll leave us with just x, right? So I'm going to continue that here, right? X to the 4th can be split up, as a matter of fact, as, look, x squared times x squared, right? Because think about it, it's x times x times x times x, or x to the 4th. Now that I've broken this down as much as I can, I'm going to start taking my nice square roots. The square root of 9 is 3. Radical 2 cannot be simplified any further, right? So I'm going to leave it as radical 2. Square root of x, the square root of x squared is just x. The square root of another x squared is also just x. But now I want to multiply this out and clean it up. So I'm going to put my radical all the way to the right. I'm going to leave radical 2 to the right, and I'm going to have 3 times x, which is 3x squared, radical 2. Believe it or not, that is the simplified answer. All right, let's move on. Now, multiplying radicals. We've kind of done that within our discussion just now. So if I multiply radical 5 times radical 10, we can multiply that, right? So as we just discussed in our rules a few minutes ago, that's going to give me radical 50. But we are never going to stop and move on to the next example until we are absolutely sure that these are simplified, all right? So in this case, let's ask ourselves again, what is the highest or greatest perfect square that can divide into 50? Good, that should be 25 and 2, all right? Square root of 25 is 5, and radical 2 is as simple as it can get. Alrighty? Now, just to go back real quick, we could have left radical 5 as is, and then we could have even broken up radical 10 into radical 5 times radical 2. We could have split that up in the beginning, and aha, there you go, look at that. Radical 5 times radical 5 is just 5. Alrighty, so now as we multiply these two together, right? Negative 2 radical 3, so it's a combination. We have a coefficient out in front, and then we have a radical right next to it, right? So I'm going to multiply the like pieces, right? So I'm going to multiply negative 2 times 4, and that's going to give me negative 8. Radical 3 times radical 5 is going to give me radical 15. Now, always we should ask ourselves, can we simplify this radical further? Well, I want to think about all of the factors of 15. Well, it's 1 times 15. Well, that's not going to help us out here, right? We also have 3 times 5 gives you 15. Neither one of those is a perfect square. So, as a matter of fact, radical 15 is already simplified. Alrighty, so that's going to bring us to our last two examples. All right, excuse me, our last example. So now, the one thing I wanted to talk, whoops, let me move that down, is to talk to you about adding and subtracting radicals. So now, as you can see here, I'm using 5x minus 9x here as a guide. I'll get to that in a second. But we should know this very quickly, right? These two terms are like terms, right? They have the same variables and they have the same exponents. Technically, this is x to the first, so is this. Even if this was 5x to the third minus 9x to the third, we could still combine these like terms. So guys, if I have 5x's minus 9x's, hopefully we are quick to realize that that's negative 4x's. Now, if you notice, the reason why I put that here is we're going to use that example with these radicals here. When adding or subtracting radicals, we must have like radicals, or basically what I'm saying is the radicands have to be the same. So if I have 5 radical 3's and I take away 9 radical 3's, that's going to leave me with negative 4 radical 3's, okay? It follows the same pattern as a variable does, right? So if I have 5 as my coefficient and I have the same radicands, we can in fact add and subtract like radicals. All right, now over here, it appears that we have different radicals. It appears that these aren't like terms. However, don't forget, we should always ask ourselves, can we simplify further? Radical 2 is as simplified as it can get. However, radical 18, let's just kind of do that on a side note here. 18 can be split up into radical 9 and radical 2, which is 3 radical 2. So check it out here. I'm going to have negative 3 radical 2 plus 3 radical 2, which will give me 0 radical 2, which is just 0. Okay, good. And that brings us to our last couple examples here. All right, again, I'm going to follow that same pattern here. These are unlike radicals. So I can't subtract 7x minus 9y. Just like over here, I can't subtract radical 2 minus 7 radical 5. I can't simplify radical 2 any further. I can't simplify radical 5 any further. Therefore, believe it or not, these are as simplified as we can get. Even over here, right? Radical 7, 8 radical 7, that can't be simplified further, but oh, wait a second. Radical 8 can be. So I'm going to carry down my -4 or -4, and then I'm going to divide or break radical 8 up into its factors of radical 4 times radical 2, right? 4 times 2 is 8. So finally, let's finish this up here. I'm going to have minus, now be careful here, the square root of 4 is 2. And 2 times -4 is -8. I'm going to carry down my radical 2. And that is my simplified expression. These are unlike radicals, therefore I cannot add them together. All right, ladies and gentlemen, I hope this was a nice review for you, and I hope you were answered some of the questions correctly.